Okay, so welcome back to part 2 of our insert production. Let's show you. If you didn't see part 1, I recommend you go back and watch it. Just let me pause this for a second. Right, so what we're producing is one of these. And the reason we needed one of these was the reel came with a hole in it like that. The axle is like that. Reel and axle doesn't really lend itself to being nice. So we've made this insert, and axle fits nice, spins like a champion. Spins so well it falls off and bounces off the floor, but you can see that's now spinning nicely, and it's got a little taper in it, and it fits nicely because it's tapered. You can push it straight into the... This has also got a small taper in it. It's about 1 mil over the width. I don't know what it is, but I could probably measure it. But I've made my taper 1 mil over the width, and that now fits nicely in there. So this will now fit nicely on that, and that now spins nicely and dispenses the filament to my printer. So that was why I've made this, and I've made it adjustable. So if you get any different size reel, you can keep that inner diameter the same and just change the outer diameter to fit the new reels as they come through. And Bob's your Auntie, you'll have yet another perfectly aligned filament feeder reel thing. So that's what this insert is. That's why I built it. I built it on the principle of a wagon wheel. It's got an inner axle and outer tyre, but in this case our tyre is made to fit nicely into the... It's got the taper on it, so it can be easily inserted and easily extracted to do the next one. Now, unfortunately for me, the next lot of reels I got has yet a different fitting. So we'll probably be playing with this at some point, because I've got like 12 of these new ones, and they're a completely different fitting. Let me pause. Okay, so I had to pause for a phone call there. I think I was talking about how well that spins on that. And of course you saw how well it fits. So that's what we're making as one of those. And now we're going to take you through the process of 3D printing this out. So once again, I bear no responsibility for anything I do, say, feel, touch, see, whatever on my videos. You follow along at your own risk. If you can't do that, click this off and off you go. But if you are happy to follow along at your own risk, buckle in and let's get into 3D printing this little collar out. I'll show you how I did it. Doesn't like it, it's ignoring it. Works for that. If I make that a 7, it ignores it. Okay, enough mucking around. There'll be a bit of editing going on, I think. Who knows? I'm going to keep it at 2. 2 works. So I'm just going to add a comment up here. Thick must be greater than 0 and less than 5. I'm just going to add that comment. I want to get that sanity check to work, and I'll do that off camera. Save it. Righto, so that's our design. We're done. There's our wagon wheel. can see my spokes aren't quite all the way to the end of the design. That's by design. I don't want them all the way to the end. Quite happy with them not to be all the way to the end because I save a bit of printing material. So let's go ahead and start this off. So what we want to do now that we're happy with this, which I am, I'm going to make this. So this compiles the design. We're sort of moving. It didn't like the battery charge, so we're going to have to charge up the other battery, which if I can find the bloody thing, and we'll get it going. But let's get this up and running. So we want to create the STL file, and I've called it insert. And I'm going to load up the Repetier software. I didn't mean to close the Repetier software down, I just did. Oh, I'm really not thinking straight, am I? I'm going to have to charge up the other battery. I just want to get a little bit of footage of that printer. So what we do is we load the image into the printer control, which is our insert. Got to connect to our printer up here in the corner. And now what we're going to do is we're going to go through the steps. So we go to slicer and we slice it. It'll come up in print preview when it's finished slicing the design. There it is in print preview. You can see this is the same as the other software. It renders it in for, that's where it's going to go. We can add the travel of the thingo so we can see where it's traveling. And I'm happy with that. I'm always happy with that. I'm going to hit print and hopefully my camera won't have stopped. You see my printer springing to life. Now, because this filament is not seated correctly. Okay, so it's a bit boring watching a 3D printer work. So what I think I'll do is I'll take you back into the design using the OpenSCAD software again, and we'll talk about how the components come together as a construction. So you can see just what each assembly is trying to do and step you through the process. And you'll see, you know, in relation to my little diagram here, you know, that it does make sense. It's logically thought out. And just while this printer's working in the background and while I'm waiting for the other camera to sort itself out, I've got some footage of the 3D printer actually working. You can see the software working there. I find that stuff boring. I just let that do its thing. What I normally do is keep an eye on the printer just to make sure that the filament isn't, you know, caught up or something like that. And you know, normally once it's going, I don't need to watch it. It can just happily print its thing out. But there are different kinds of filament, and currently the filament that I'm using is giving me some real grief. It's not calibrating. It's not sitting on the bed in the same way that the other filament I had sat on the bed. So I need to recalibrate the printer. Excuse me. Recalibrate the printer for this particular filament at some point. But right now this is working fine. I've got the older filament in there, and I'm just going to talk you through the design and show you how the modules assemble within the software. So here we go, back to OpenSCAD. Alright, so let's build that, and there you can see I've got a hole through my outer ring. That's my outer ring done. So that was the first piece I built. Next thing I had to work out the spokes. To do that, I had to build one spoke. So now I'm going to show you one spoke with my assembly. You'll note that I'm actually giving it the command above my modules. Okay? So assembly 1, we're going to see it with one spoke. Why am I getting that? Oh, okay. I built, because I hollowed out that cylinder, I put a new cylinder in. And once again, that thickness is going to be wrong. I only added one thick, which means I've got a 1.5 millimeter thickness around that inner one. You know what? The 1.5 millimeter thickness is actually working, but it's not good programming, so I'm going to change it. Now this is the beauty about changing your mind in a design that's modular, right? So I'm building this inner cylinder here. That's this cylinder, and it's got one spoke in it. I'm just going to comment the cylinder out really quick. So you can see the spoke is going from the center to the edge. Now I'm going to put that back. Does everyone understand that? That spoke, I don't want to trim it up to the cylinder because it's too hard to do the rotation. It's just too hard. You can rotate them around, but it's easier to do one bore through the whole job. Likewise, I could have bored through this cylinder. I could have chosen to bore through that and just add it as a thing, but then I would have had the spoke coming to the middle and I would have had to bore it out again. So I didn't want that. So now I need more spokes. I need 6 of them, right? So the way I did that was I've got a rotation angle here, and I'm rotating and building 360 degrees over the number of spokes. So if I've got 6 spokes, 6 is a 30, I'm rotating 60 degrees, and I'm building my spokes. So I'm using a for statement from 0 to the number of spokes minus 1. And I'm changing that rotation angle by the value of A and looping it around and building a new spoke for the number of spokes. So instead of spoke, I'm going to say spokes and rebuild that. And there they are. There's our 6 spokes in our for loop. Pretty cool. We're nearly done. Now all we need is to put our hole back through the center. So we just need our bore, and our bore is there. Now this cylinder, I could have put that in my outer. So I can take it out of here where it makes no sense. Control V, and put it in there after the difference. And you can see that didn't change at all. You just comment that out so you can see what's going on without that cylinder in there. Oh, Control Z. Oops, redo. I'm hitting the wrong buttons. I'm commenting out the wrong cylinder. Sorry guys. Here we go. So there's the spokes and the outer. So this outer here really has to have that cylinder in. It belongs with this. That's all of the outer built. Now all I've got to do is put the ball back in. Get rid of this. Run it, and there's our bore. Now it's got a bigger bore in it this time because we changed it. Now remember I said the 1.5 worked? I can drop this from 3 to 2. Watch what happens. Bang. Way, look at that. She just changed. If I want to make it 8, I can make it 8. Watch what happens if I make it 8. Woo! That really gets going, doesn't it? So 8 doesn't really work. So I can put an if statement in there and say if thick is greater than 8, make it 7. At 7 I'll get a little bit of a gap somewhere. No. What about 5? There we go. At 5 I get a little bit of a gap. Maybe at 6 I'll get a little bit of a gap. So I could put an if statement in there. If thick greater than 6, thick equals 5. Or, you know, if thick greater than 5, thick equals 5. I can put an if statement in here. So I can do some... I'm going to do it. I'm going to do a sanity check. And I'm going to run from the cheat sheet. So I'm going to go help in my cheat sheet. I need the if statement. So I'm just going to open this up. Got to make sure you've got an internet connection. Slow. Don't know why the internet's so slow. Oh, maybe it's the computer that's slow. Who knows? I'm making hard work of this, let me tell you. Here we go. And our if statement is here. I'm just going to grab the syntax for the statement and copy it in. So now we've got a little bit of sanity checking in our code, which is always good to have. So if thick Control V is greater than 5, then we want Control C, and close our bracket. So now let's make thick 7, and that won't change. Well, yes, it will. Okay, what did I screw up? Alright, so this is still going to be printing for another 2 hours. I'm not going to bore you by showing it to you work for hours and hours and hours. I'll give you a close-up of the job. Alright, so I'm going to pop this up. There goes the printer. Check that that's being caught. It's being caught. Alright, so that's going to be printing out for 2 hours, according to this. 2 hours and 3 minutes ETA, estimated time of whatever. 2 hours and 3 minutes. So, we'll come back in 2 hours and 3 minutes and I'll show you the end product. I can't believe I've done this 3 times now. I've been having a bit of a camera thing. It's the next day. I just wanted to finish this video up. I thought I had the camera going, and I've been talking to this camera and doing shit for, I don't know, 20, 30 minutes, and it hasn't been on. It's just been me talking to a computer. yeah. Shot in the head. Look, I'll tell you, here we are. I want to show you the final product. I've actually got it inserted into the thing. Now what I had done was show you pulling it off the printer. But there it is, popped out. That's what we ended up with after we trimmed it up a little bit of the collars and things that the printer puts on so it can print out and it doesn't move. I didn't bother trimming it up too much, just the interior yoke needed to be trimmed up. And as you can see, it's a tight fit, which is what I wanted. And it pops in there. It did pop in there. Oh, I got it backwards, didn't I? Pop it out again. But it pops in quite nicely. I'll just put it this way so you can see. There's a little bit of a taper to it. And when you push it in from the tapered side, I put a 1mm taper in it, and you just push it in there, and it just slides straight in. And that insert is now finished, and it works beautifully. It works absolutely beautifully. So I'm just going to wind this back on now, put it back into the other bit. As you can see, it slides straight in. The extra 2mm clearance has done wonders for it. It'll turn beautifully, do what it needs to do, and life's good. Right, so this is part 2 of a 2-part series, and if you didn't see part 1, I recommend you go back and look at that. What I'm attempting to do here is keep it simple, talk about modular systems and modular design. For example, here's another thing I'm working on. This is a ball bearing roller coaster, so I'm going to be running ball bearings down this thing. Now here's a spiral. This was my first attempt at the spiral. This was a chute spiral, and the idea was that this would feed into this, you know, then you'd add a sharper curve to it or a smaller curve to it, and then you'd put on a straight piece, and then you'd drop into something else, and you'd have a long shooty curvy thingy. You know, all of these pieces I 3D printed because I've recycled the software and made it modular. And the foot that's on this piece, right, is the same foot that's on this piece. It's actually the same bit of software, just with some variables changed, right? So I've changed the shape of the curve. I've changed the angle of incidence and reflection on it. And these feet are exactly the same, right, on every piece. This collar here is the same as this collar here. It's the same. Some of these are failures. You know, some of these didn't work out the way I want them to work. But, you know, they'll get recycled. Writing modular systems is good. You know, recycle your code, write it so that other people can read it and understand it, and get to the idea or habit of writing things down. You know, give yourself a written plan to avoid this feature creep of, you know, I could have put studs on the wheel, I could have put lights on it, you know, I could have done any of these things. And basically, because I didn't want any of that, I wanted a very basic piece. I had it written down, and as I thought of these things, you know, basically, if you don't have it all written down, you don't have a clear goal that you're trying to hit, you can be programming along and think, shit, it'd be good if I put a light in this thing. And so you start programming for a light, and then you say, no, I don't want a light. And then what have you done? You've programmed for this light, it's feature creep, you don't need it, and you chuck it out, and you've just wasted your life. You know, time is precious. It's too precious for you to do rubbish like that. Give yourself a clear idea of what you want to go after and go after it. You know, that's it. Now that works whether you're doing a design on the computer, or whether you're trying to get something for yourself, if you want to buy a new car, if you want to buy, don't pay it off, buy it. Put the money away in a bank until you're ready to go, and then go get it. It's yours then. You're not, it doesn't belong to somebody else, and they can't take it off you. If it's yours, it can't be taken off you unless you, unless you prang it. Then it can be taken off you. Probably wouldn't want it after you prang it. Who knows? But this is called the satisfaction that comes with achievement. And the satisfaction that comes with achievement is something that you've got to learn. It's something that you've got to do for yourself. It's something that you can share with your partner and share with those around you. It makes positive, like they see you getting this and they see you achieving your degree at uni, or you bought something for yourself which you own, and that's the way it is for us. If we can't afford it, we don't get it. We don't go out and put it on hire purchase or credit or pay it off on a lease. We don't do that. We go out and we pay cash for whatever we want, and we can bargain. We're in a strong position because we say, look, that's what we've got for it. You either take it or leave it. Most times they take it, sometimes they leave it. Most times you get what you want for a little bit less because you paid cash. You went in and you said, there it is. I'm not paying it off. You're not talking about a gazillion, miles of paperwork to get it to happen. It's a simple thing. Here it is. Here's cash. Give me that, and I'm out of here. I'm done. People love those transactions. They're very simple to process. They got paid their money. They're happy. You're happy. Life's good. Okay, let's talk about do good things, make good decisions, be uplifting. Be positive. Keep swinging at your goals, and I will see you at the next video. And for those who are wondering about my health, it's actually going pretty well, other than the neuropathy. I've got some issues with side effects from the cancer treatment, but that's the reason I haven't posted in a while. So if you're following along with my channel, there's a bit of a gap in the videos. That's why I've been a bit crook with the cancer treatment. But I'm back on deck, and I'm getting back into it. So hopefully I'll see you at the next video. Make your comments below, like and subscribe to the channel, and don't forget my nightglowmanufacturing.com. And I'll see you guys at the next video.